Write the differential equations governing the mechanical system shown in figure. There are three masses are there. M1, M2 and M3 are the three masses. They are connected through the springs K1, K2, K3 as well as B1 and B2. The force is applied at M1. Now we have to obtain the mathematical model in time domain. That is differential equations we have to write. First consider M1. What are the forces acting in? The applied force F of t is acting on it. And what are the reaction forces? The reaction forces because of mass is M1 d. What is the displacement? X1. D square x1 by upon dt square. What are the other forces? Because of spring K1. K1, other end of the spring is fixed. That's why K1 multiplied by x1. Because of B1. B1 multiplied by dx1 upon dt. One more reaction force because of the spring K2. Because of that K2, both ends are free. Both ends are free. The K2 is connected between M1 and M2. K2 is connected between M1 and M2. That's why both ends are free. Displacement at this end is x1. Displacement at this end is x2. Therefore, because of this K2 multiplied by x1 minus x2. Both ends are free means, and displacement direction is same. That's why x1 minus x2. That's all. Therefore, the first mathematical equation for the mass M1 is F of t, applied force, equal to M1 d square x1 by dt square plus B1 dx1 by dt plus K1 x1 plus K2 x1 minus x2. That's all. The first equation is over. Why we wrote F of t one side and all other forces on the reaction forces on the other side? They are in opposite direction. F of t is downward. All other reaction forces are definitely upward. So that's all. The displacement in this mass is x1. Now, if you take the free body diagram for M2, what are the forces? No applied force on M2, but only reaction force. What is the direction of displacement? Direction of displacement is downward. Therefore, reaction forces will act upward. What are the reaction forces? M2 d square x2 by dt square plus spring K2 is connected, but it is connected both the M2 as well as M1. Therefore, K2 multiplied by x2 minus x1, because x2 is reference. Earlier, how we wrote x1 minus x2 while considering M1. But here, while considering M2, we have to write x2 minus x1. Because the direction x2 is considered, therefore, x2 minus x1. Plus, that is the only difference. Then, K3 is connected here. K3 is connected here. K3 is connected here. Therefore, the reaction force because of K3 is K3 multiplied by x2 minus x3, because both ends are free. Similarly, B2 also connected. B2 also connected. Therefore, because of B2, the force acting on it, reaction force acting on it is B2 multiplied by x2, derivative of x2 minus x3. x2 minus x3. That's all. Therefore, the equation for second mass is 0 equal to, because no applied force, 0 equal to M2 d square x2 by dt square plus V2 d upon dt of x2 minus x3 plus k2 multiplied by x2 minus x1 plus k3 multiplied by x2 minus x3. That's all. For second mass. Third mass, what are the reaction forces acting on the third mass? The reaction forces acting on the third mass, no applied force, only reaction. Displacement is downwards. Therefore, the reaction forces are acting upward. The first reaction force is Fm3. The second reaction force is Fk3 and Fv2 are the three reaction forces acting on it. What is the equation? 0 equal to m3 multiplied by d square x3 by dt square plus K3 is connected both M3 and M2. Here X3 is considered as X3 displacement is considered as far as M3 is considered. Therefore, for this dashpot V2 multiplied by d by dt of x3 minus x2 plus k3 multiplied by x3 minus x2. That's all. So these are the three differential equations governing the given system. For one system, there are three differential equations. So how many differential equations will be there? Number of differential equations equal to number of masses. Number of differential equations equal to number of masses. That's all. So if it is the electrical system, number of differential equations equal to number of loops. If it is KVL. If it is KCL, number of differential equations equal to number of nodes minus 1. Because one node will be taken as a reference. So while writing KCL, you will find the number of nodes. Now after finding number of nodes, what you will do? One node will be taken as a reference. For remaining nodes, you will write KCL. Therefore, number of equations for KCL, current equation, Kirchhoff's current law, if you write number of equations equal to number of nodes minus 1. If it is KVL, Kirchhoff's voltage law means number of equations equal to number of loops in that circuit, number of loops in that circuit, number of closed paths in that loop. As far as mechanical system is concerned, number of equations equal to number of masses. M1, M2, M3, three masses are there. Therefore, three equations. That's all. So these three differential equations together represent the given mechanical system. Together represent the mechanical system. That's all. As far as this question is considered, what is the question? Write differential equations governing the mechanical system. That's all. So answer is over. You have to draw the free body diagram. You have to mention all the forces acting on it, applied forces as well as reaction forces. Then you have to write the equations. That's all. This is for electrical system. As far as the electrical system is concerned, if it is a resistor, we can write the equation for voltage across the resistor. What is the voltage across the resistor? I multiplied by R. R is constant, I is variable. So current through this resistor is voltage across the resistor. Voltage across the resistor VR equal to voltage across the resistor equal to Ri. What is the current through the resistor? I equal to, what is voltage across the resistor? V divided by R. That is current through the resistor. If you write expression for current, V by R. If you write expression for voltage, IR, you can write the expression in terms of charge also. What is the definition for current? Rate of change of current. Rate of change of current. The velocity of electron is current. Actually, the velocity of electron is considered as current. Current itself is dynamics. Current means dynamics. So that is velocity, dq by dt. Rate of change of charge in a circuit is current. Therefore, instead of current, we can put dq by dt also. Therefore, voltage across the resistor equal to R dq by dt. dq by dt. If it is an inductor, what is the voltage across the inductor? L di by dt. The current through the inductor is I. Voltage across the inductor is V. In that case, V equal to L di by dt. What is current through the inductor? 1 by L, 1 upon L, integral of V dt. We have to integrate the voltage. If you consider current I equal to dq by dt, then di by dt becomes what? I equal to dq by dt. What is the derivative of current? T square q by dt square. Therefore, we can write voltage across the inductor can be written as L d square q by dt square, because I equal to dq by dt. If we differentiate, therefore, di by dt equal to d square q by dt square. That is substituted here. In the case of capacitor, what is voltage across the capacitor? V equal to 1 upon C integral of I dt. Integral of I dt. What is I? Current through the capacitor. I equal to C rate of change of voltage. C dV by dt. But I equal to dV by dt. I equal to dq by dt. dq by dt. Therefore, if you integrate on both sides, di dt, integrate on both sides, integral of dq by dt multiplied by dt. Integrate on both sides with respect to time. You will get dt getting cancelled. Therefore, you will get q. Q equal to integral of I dt. Integral of I dt. Q equal to integral of I dt. Because I equal to dq by dt. Therefore, integral of I dt equal to q. Here, integral of I dt is there. So we can replace this integral of I dt by q. Therefore, V equal to q upon C. V equal to q upon C. We can replace integral of I dt by q. Therefore, V equal to q by C. Why all these equations? Why the up to second column already you have seen? Why all these? This fourth column? Why? That we are going to see now. Before seeing that, what is out of these four equations, which is familiar with you? V equal to 1 by C integral of I dt. Am I correct or not? Most of the times you used this 1 by C integral of I dt equal to VC, voltage across the capacitor. So if you remember this only, all the remaining four you can easily remember. So what is VC equal to 1 by C integral of I dt means? These two are if you write for VC, if it is integrator, you have to write for IL. Instead of 1 by C, 1 by L. VDT. So instead of I, V, VDT. That way you can remember for integrator. If you remember for capacitor, you can easily remember for integrator. The opposite way. Replace V by I. That's all. Replace I by V. You can easily remember. And we know that this also you can easily get. If you differentiate on both sides, what you will get? So you can easily remember this. So from that you can identify this. Replace I, V by I, 1 by C by 1 by L, I dt by V dt. That's all you can easily remember. If you differentiate on both sides, what you will get? This equation. C dV by dt you will get. If you differentiate on both sides, you will get dV by dt. Here you will get I. If you bring that C here, you can get this. So in the same way, you can remember this. Replace I by V, C by L. That way you can remember. So if you remember this one formula, you can get all other three. But these three are important. Why? That we will see now. Analogous systems. For a mechanical system, we can find an electrical analogous system. Electrical analogous system means the differential equation governing the systems for electrical as well as mechanical are identical. What is the mathematical model of this given mechanical system? What is the mathematical model of this given mechanical system? Displacement, the applied force is f of t, the displacement is x, the velocity is v. Therefore, the mathematical model is f of t equal to, because of mass m, d square x by dt square. Because of this b, you can write b dx by dt. Because of this k, you can write kx. That's all. This is the mathematical model in time domain. What is the mathematical model of this electrical system? The electrical system is V of t equal to V of t. The applied voltage is V of t equal to the current through the circuit is I. If you write KVL, what you will get? Ri, the drop across. If you travel along the current direction, if it is a battery, you are traveling from negative terminal to positive terminal. That's why this is positive. V of t, you can write positive. Why positive? You are traveling from negative terminal to positive terminal. If you travel along current direction, you would put minus Ri minus L di by dt, because the potential drop across inductor is L di by dt. What is the drop across C? Minus 1 by C upon 1 upon C integral of I dt. If you bring all these to the right hand side, you will get this equation. So this is the mathematical model of the given electrical circuit. If you write in terms of charge, what you will get is, if you write in terms of charge, you will get V of t equal to I L di by dt. We know that I equal to dq by dt. Therefore, L d square q by dt square. This is replaced by L d square q by dt square. We are writing in terms of q, not I. I is dq by dt, that we know. Therefore, this Ri becomes R dq by dt. I equal to what? Di by dq by dt. If you replace I by dq by dt, dt getting cancelled, integral of dq is q, therefore q by c you will get. We are writing in terms of q, in terms of charge, that's all. If you see this equation, say A. If you say see A and B, if you see A and B, B is differential equation governing mechanical system, A is differential equation governing electrical system. If you see here f of t, here f of t, here v of t, here v of t, here m d square x by dt square, here L d square q by dt square, here b dx by dt, here r dq by dt, here kx, here 1 upon c q. Both equations are identical, not equal. Identical equations are there. If L equal to m, R equal to b, if L equal to m, R equal to b, and 1 by c equal to k, both systems are analogous systems. Which is simple. Construct, suppose you want to construct a system, you will be given RLC. You are given spring, dashpot, and mass M. Which is easy to construct? Electrical or mechanical? Mechanical. Electrical or mechanical? This is simple system. That's why you said mechanical. Mechanical system, how you will connect K? One end should be fixed end. Other end it should be connected to mass M. Is it simple to connect mass and another end is fixed place you have to connect? Similarly, dash part has to be connected. You have to weld. If it is electrical system, how you will connect the resistor and inductor? Just twist, that's all. Simply you can construct. So, if R, L, C, resistor, inductor and capacitors are given, which system can be easily constructed? Electrical system, not mechanical system. Constructing mechanical system is difficult. This is simple system. That's why you say mechanical system is simple. Electrical system, just connect R, L, C and connect a battery. That's all. Which is easy. Since you are a circuit branch students, you must have said electrical system than mechanical. If you want to connect a spring with the mass, how you will connect it? You have to weld. Or some means you have to connect. If you use a screw, what will happen? There will be change in mass. The electrical system also there will be a change because of connection, but if it is negligible, then okay. Anyhow, constructing the electrical system is simple. Constructing electrical system is simple. Suppose this system, which is simple, electrical or mechanical? Definitely electrical system. So, for any complex system, we can easily get a electrical system. Therefore, instead of doing experiment on mechanical system, we can do the same experiment on electrical system. We can find the output. Suppose you designed a mechanical system. For that, you want to check practically, but very complex system. Very complex system. Conducting experiment on this very difficult. So construct the electrical system and do the simulation. But nowadays you have computer simulation. That's why it appears simple. It appears simple, computer simulation. But those days before inventing computers, how they simulated mechanical system by electrical system. So they need the analogous systems. So any mechanical system can be converted into electrical system, analogous electrical system, so that they can simulate and find the output without conducting mechanical experiment. Without conducting mechanical experiment. Similarly, if it is a biological system, for that you have the set of differential equations. For that you can construct an electrical system, you can conduct the same experiment electrically. You can conduct the same experiment, you can find the output. Instead of X, you will get Q out. Q is there. X there, displacement is X there. What is the equivalent variable here? Q. You have to find the Q. If you know I, from that you can find Q. If you know the I, you can find the Q. That is the only difference. So, finding analogous electrical system for a given mechanical system is important. So, now let us find the analogous electrical system for a given mechanical system. Before going that, how you can get a mechanical system, electrical analogous system for a given mechanical system? Replace M by L, replace B by R, replace K by 1 upon C. That's all. You will get, you find the L, which is equivalent to M. You find the R, which is equal to B. You find the 1 by C, which is equal to 1 by K. Find a C, which is equivalent to 1 by K. So you have to find the inductor whose value must be equal to M. You have to find a resistor whose value must be equal to B. You have to find a capacitor C, its value must be equal to 1 upon K. That's all. You can construct a electrical system. So now what are the equivalences? For a given force, the equivalent analogous electrical system, voltage V. For velocity, dx by dt. Velocity means dx by dt. Here current. Here mass M means here inductor L. Here viscous friction coefficient B means here R, resistance. Here displacement X means here charge Q. Here stiffness constant K means 1 by upon C. Therefore, C equal to 1 by K. To find C, we have to find 1 by K. That's all. You will get electrical equivalent circuit. Now let us find electrical equivalent. Already we found the electrical equivalent circuit for this system. This is the mechanical system. For this identical analogous electrical system is this one inductor, one resistor, one capacitor. That's all. If you put all these things, you will get this electrical analogous system. That's all connected in series. Only one loop. How many equations are there? How many mechanical equations are there? One. Therefore, in the electrical system, one loop will be there. So all are in series. That's all. All are in series. But here, how many equations are there? 3 equations are there. 3 equations are there. Therefore, 3 loops will be there. In the electrical system, how many loops will be there? 3 loops will be there. We'll draw that circuit now. 3 loops will be there. The first loop, what and all there? F of t. That is V of t. Already we have seen. Applied force is identical to F of t. Applied force is identical to V of t. Already we have seen. M equal to what? L. B equal to R. That you have to remember. So now we can find the M equal to L, inductor. L1 equal to M1. L1 equal to M1. B1 dx1. What is current through this? I1. Current through this is I1. So V equal to what? R. Therefore, R1. This is K1. Therefore, C1. C1 equal to 1 by K1. That's all. This is 2 variables involved. As far as K2 is concerned, X1, X2. X1, X2. That is Q1 minus. Am I correct? Q1 minus Q2. You will get Q1 minus Q2. Therefore, it involves both the loops, first loop as well as second loop. Therefore, we can write C2 equal to 1 by K2. What is current through this? I1. In this loop, current through this is I1. Here I am going to draw another loop. Here I am going to draw another loop. Here I am going to draw another loop. In that loop, current is I2. What is the current through C2? I1 minus I2. If you write equation for first loop, how you will write? Current through C2 is I1 minus I2. If you write equation for second loop, how you will write? I2 minus I2. I2 minus I1. So consider the second equation. In the second equation, M2, L2 equal to M2. B2, that is C2. B2 is X2 minus X3. We'll write later. K2 multiplied by X2 minus X1. Already we have drawn that C2. Instead of K2, already we have drawn C2 equal to 1 by K2. Here it is identical to Q2 minus Q1. Q2 minus Q1. So for this, X2 minus X3, here one resistor is there, that is R2 equal to B2. R2 equal to B2. Current through this is I2 minus I3. And one more K2 is there, that is one capacitor is there, that is equal to C2 equal to 1 by K2, 1 upon K2. That's all. That's all. How many elements? Inductor, here one capacitor, on 4 elements. Yes, in this loop 4 elements. Second loop is over. Now we have to draw the third loop. Third loop will be here. Third loop, x2 minus x3. This is in third loop as well as second loop. That's why it comes here. Third loop is here. I will explain one more time, don't worry. Third loop is here. What is current through this third loop? Current through this third loop is I3. I3. Therefore, here this comes under third loop and second loop. This also comes under third loop and second loop. Now consider the third equation. M3, one inductor is there. M3, that is L3 equal to M3. And this is common to second loop and third loop. Already we have drawn that. R2. This is also common to second loop and third loop. That's all. That's all. This is the analogous electrical system. Analogous electrical system. That's all.